Now we're going to talk about classifying a number by the number system to which it belongs. Natural numbers are used for counting. 1, 2, 3, 4, 5. Whole numbers, they include all the counting numbers and 0. Integers are the numbers that you would normally think that you would see on a number line. They are not fractions or decimals, but they can be positive and negative. Rational numbers are numbers that can be expressed as a fraction. In other words, they're not a repeating decimal. I mean a decimal that doesn't end in end, and I'll talk about that in a minute, what that means. Irrational numbers, those are ones that are not perfect roots, and we've discussed that in a previous lesson, but I will go over it again. Okay, so you're just going to run down the list for each one of these. The number 30, yes, you do need to count. You do use it to count, so that's natural. It is a whole number. It is found on a number line, not fractions or decimals. You can have fractions and decimals on a number line, but those are not integers. Rational numbers, 30 ends. It doesn't have a decimal that we need to talk about, so it's automatically rational. 5 and 4/7. Okay, that's the same as 5 point, let's do 4/7. 4 divided by 7. All right, I want you to notice how this just keeps going. And the reason it stops here at this 7 that I am pointing at is because it doesn't fit on the calculator. It does have a repeating pattern, 5, 7, 1, 4, 2, 8. 5, 7, 1, 4, 2, 8. 5, 7, 1, 4, 2, 8. So, we do not use it to count. It's not natural, it's not whole, it's not an integer because there are decimals involved. Rational numbers, so the only thing that it can be is either rational or irrational. Now, because this is a repeating decimal, it repeats a pattern. So it is rational. If it does not repeat, it is irrational. And you can think of that as rational repeats. They both start with a letter R. Okay, the square root of 21. Let's look at that. I already know it's irrational because it's not on the list of perfect squares. Okay, 5, 8, 2, 5, 7, 5, 6, 9, 4, 9, 5, 8. There's nothing repeating. There's not a pattern that repeats over and over and over again. So because it just keeps going and it doesn't repeat, it's irrational. Natural, whole numbers, integers, all three of these will have no decimals. That's why I didn't even look at them for the one I just did. Okay, negative, you do not count when you're playing hide and go seek or whatever, you don't count with a -9. Well, actually, let's talk about that. This is not 9. The square root of 9 is 3. So this is really talking about the number -3. You still don't count with it, so it's not natural. It's not a whole number because whole numbers are the counting numbers with 0. It is an integer. And because it's not a decimal that just goes crazy, it's rational. Zero, you do not count with 0, so it is not a natural number. It is a whole number. It is found on the number line as an integer. And it ends, so it's rational. -16, you don't count with negative numbers. It's not a whole number because those are counting numbers with 0. It is an integer because those are allowed to be negative. And it ends, so it's rational. 6 over 2 means 6 divided by 2, which is 3. We do count with that, so that's natural. You just take the list and just keep going down for each one of these. It is a whole number, because all natural numbers are whole numbers. It is an integer, because there's no decimals or fractions. And it ends, so it is rational. Square root of 7. 6, 4, 5, 7, 5, 1. There is no repeating pattern, so this is going crazy. It doesn't end. It's irrational.